Yeah, the recording is started, and I'm literally just gonna go for the practice paper today because I waste a lot of time just doing keys, which may not necessarily come up, but they're a good practice of like doing linked lists and templates, or it involves all of that. Right, so I made the empty projects for this practice test because for each of the sections it asks you to create a project and then create some files in it. So I just made the 4 projects for each section. Feel free to ask questions along the way as well. Your voice is not recorded, just mine is. I don't want to. So create a project class, create a new source file, name it test1 as I did, and then I kind of started it last time, but then I'll do it quicker this time without explaining then. Create a main method for it to run. Do the return. Yes, I am. I'll double check, but yes. Should be recording. Include IOStream to print stuff. And using namespace std to type less. Now what's it asking to? It's asking to get us double variable c, give it the value of the speed of light. So double c equals speed of light. Pointer to c. So because the pointer to double, it has to have double type, and then the pointer asterisk. And we call it PC. And to make PC point to the variable, we take the variable and we get its address by using the and sign before the variable name. Then use pointer based operations to square it. So what we do to get the value at P at C, we take the pointer and we dereference it. That takes the address of C and gets the value in it. So now we can assign this value. I can make it 10 if I wanted to. But instead what we want to do is I want to make it itself squared. So I need to get the value at C again. So that'd be PC. And multiply it by itself again. I put the brackets there for it to be more visual, but you don't need them. But then this can be simplified because we have a times equals operator, which allows us to multiply and assign. So we multiply the value on the left by a certain value and then assign the result back to the value on the left of the equals sign. So times equals, and then we don't need one of those because we're using one of them to multiply. So if you're okay with that so far. Oh yeah, sure. Is good enough? Great. I can make this bigger as well if you want to read the spec. So we're told to rename the main function, and this is done to make sure it doesn't run when I want to run another main function. Oh, actually, I didn't finish this. Print out the squared c value via the pointer. So we can't just do cout c because the question tells us not to do so. So what we have to do to get the value at c again is just use a pointer and dereference it. To get the address of c, which is stored in PC, and then dereference, get the value, and you can add slash in. Just go to the next line when you print. Build errors. Okay, nice. I like that. Oh, and because I renamed main. Yeah. So take the value, squares it, and prints it, but then the formatting of the output kind of puts it into this like mathematical form with like uh, significant figures and like 10 to the power or something. Ah, okay. So C is just a variable. It is stored on the stack, right? It's a local variable, so it's stored in the stack. PC is a local variable of the type pointer. So it's also stored in the stack, but it has the value of the address of C on the stack, so we can get the address in memory where C is. And then I can probably print it as well, so I can print out to get the address. I can print it. So we're storing the address of C in the pointer, which is just a type of local variable. Then what we're doing is we're accessing the memory. I'll print this first. So breakpoint. So we got to here because I put a breakpoint and the pause the program. So we are printing the address where the variable C is stored. So if we go to that address, where's it up? Debug Windows memory. What? Yep. And then you can copy that into here. I think those should be this value here. If I try to convert it, I can get a calculator or something. Ah, fair. I mean, you're gonna trust me that this is the right value then? Like I did it last time, so I'm gonna comment this out and I'll put a value I can recognize. So um, make it 11. Alright, make it 9. And we're gonna do the same thing again. And then it's a new address, because stuff has changed in memory after we ran the previous program. So it's gonna allocate in a new position. I go to that, and then 1, 2, 3, 4. Is it right though? I'm trying to find it. I mean, it should be here. It's just right. Problem with doubles is the way it's stored is like the format. It's not just number itself. So if I make it int, because you know the IE whatever T like format for floating point, it messes up the value by storing like the like part of the significant figures and then part of the exponent too. You spent them one last time, and then I'll stop. And here it is. So it's an integer stored in the stack and has the value 9. We can get its address, we can find it in memory, and then using this address we are able to change it. So same thing for double, it's just for double, like the value will not look the same as what we want it to look like. We cannot really identify what the value is by just looking at the hexadecimal. But here it's a 9, so it has like 9 times 1, 0 times 16, 0 times 16 squared, 0 times 16 to cubed, and like so on with the powers of 16. That's that. Change it back to the question. So that's what we have those types of variables for, which are pointers, to be able to store the memory location and then access the memory location by dereferencing and to be able to change the value at that memory location. So we're changing C the whole time, we're just accessing the memory of C through the pointer. So we're okay with that. Alright, I'll move on to the next question then. We can come back to that if we need to. So rename the main function to main1. Probably just paste a new main function in. I'm not leading it. Yep. Which one of those? This one? This is a times equals operator. So multiply and assign. It's the same as doing this. Yeah. It just kind of shortens it to this. No, I mean, I can leave it. It's like you get the same marks for it. Probably get less confused. And I'd put the brackets around this. So then what's next? So there's this function which they give us, and there's supposed to be a bug in it. So they tell us what it takes an integer array, a pointer to the integer array, which is basically pointing to the first element of the array, and then the size so that we can like shift the pointer to get to other elements of the array, and then the value with which to populate the array. So we're going to put this value into each index of the array. That's what the function is supposed to do. So we're supposed to put it in, but there's a bug, so when we run it, it's not going to work as intended. So we create an array. I'll create it like this. Array. Oh, it's a keyword. Where is it? And as I mentioned last time, there's two ways to create arrays, two ways to create like any object. You can create it on the stack. Like this. So just the type of the array is holding, the name, and then in square brackets the size. Or in the heap, using the new keyword. So then what you're using is new, the type that the array is holding, square brackets, and then the size inside them. But also this statement will return you the pointer to an integer on the heap memory. So what you're going to store is an int pointer. So it's similar to what we did here, but we got a pointer to just one variable. In this case, we're getting a pointer to an array of variables, and we can go like shift off the base pointer, which will be pointing to the like 0th element, the very start of the array, to get to other elements. I'll probably do an example of both. if we want to fill it, we pass a pointer to the array, either this one or this one, because they're both basically integer pointers. And we pass the size in, and we probably want to store it somewhere. Int size plus 10. And then the value populated. Oh, you see with stack allocated arrays, this value here has to be constant. So it has to be kind of known at compile time. Const is how you make a constant, and then there's no issue of this. But it's only for this stack allocated array, not for the heap one. Size and the value populative. So there's a bug in here, so supposedly this will not work. And we're getting corrupted array error. And then if you go to the stack, well, so the error is not really telling us anything, right? But we were told in the question that there's a bug in this function, so this function has a bug. So we're told to correct it. So we can look at the function to figure out what's going wrong. So what the function does has a while loop, and it iterates until size becomes 0. So when while size is greater than 0, it continues to do this. As soon as size becomes 0, it stops. This size minus minus in here, what's going to happen is take size, compares it first, and then it decrements. So it's as if doing this. And you also, because it was a one line in the while, they didn't use the curly braces. But when it's more than one, you have to use curly braces. So this would do the same thing. So you're taking size, comparing it. Probably can move it here. Then you're like decreasing it, but you're still doing whatever's in here. So just remember, when it's on the right, you're decreasing the size after doing like the outer like operation with it. If you put it on the left, you're first decreasing size and then doing the operation. So this will produce a different result. So then what we're doing is we're taking the pointer of the array, we're dereferencing it, we're assigning the value we passed in, which is 99 for us, and then we're decreasing the pointer. But because the pointer starts off pointing to the very first element, so like whatever address it returned here, so like it'll be like a certain address, like OX, wherever, DDF, whatever. And then that'll be the first, where the first element is on the stack. The next element will be 4 bytes down because an integer takes up 4 bytes in memory. So D is 13 in hexadecimal. So if we add 4 to that, we go over the top, so that'd be 14, 15, then it goes over to 1 and then 2, and then this will go over by 1, it'll become 0 because F is the last digit in hexadecimal, and this will go up 1. That'll be the next one. Next element would be at position 6 and so on. So like you go up in 4s in hexadecimal just. So A, that has to become 10, but then 10 is represented by an A. in hexadecimal. So that's B. Right. So what we're doing in here, what this contains, this like int array heap contains, is always just this address. So if we print it, we should get, I mean, not this exact address, but like the address that this allocation returned. So wherever the whole array is. So to get each element, we need to shift this base address stored in the array variable to get to the next one, and they're shifting downwards. But because it's holding the first address, shifting downwards will go down the number. So instead of going up by 4, we're going down by 4. So we're going to element -1, which causes this error. So that'd be 9 then, because D is 13 in hex. Right, so that's what's causing the issue. We're supposed to go up from the base address, get to further elements, but we're going down. So what we need to do is change it to ++. And then the code runs, but then we don't have any output, so it doesn't show anything. So let's just check it. Let's do a loop and print each element. I think I'll just do a normal loop. I used an enhanced loop yesterday, but then we weren't taught it, so we shouldn't really use it. It gets stuff more confusing if you use it. Well, Jai will know what it is, but just in case for anyone who doesn't know it, I'll use a normal loop. So from 0 to size, so from 0 to size but not including size, that'll be the values of I. For increasing I of each step, we are taking, which one? We used stack one, right? We're taking the elements at index I and we're printing them, so cout the element, and I also want a space between them so I can distinguish them in the output. And then a good practice is to take a new line, because any further prints you do will go in the next line then. Otherwise they stay on the same line and then get everything concatenated into one line. That's how you usually print out any array. Just go through the elements from 0 to size, get the element, print it. So I can print it before and after the function. So before the function, it's just some random data that it's in there. And it seems to be the same value because it's like all C's in hexadecimal, I think, because it was unused memory, and unused memory is marked with like all C's in hexadecimal for the computer to know that it's unused, so you can use it, or at least it's marked as all C's in Visual Studio. And then what we're doing is we're populating it with 99. So that's with the stack array, exactly the same process with a heap array. They call it heap. Well, they might a bit. Do we know the difference between stack and heap, by the way? I keep mentioning it. Just in case. Give me a shout if you don't. I'll get my paint out. Just imagine it. This is your RAM stick, right? Yeah. So the stack, yeah. So this is all memory, right? It's just like a chunk of like data, right? And it has like a certain address, so it starts from like address of byte 0, going address byte 0 here. So like 0x, and we're going to use like 32-bit, so it's just 4 bytes. So each 2 hexadecimal digits is a byte. So we got 4 of those, and that's 32-bit. So the older computers would have 32-bit memory addresses, so it means they're limited to a certain capacity because the address is limited to a certain max value, so you can't represent more addresses, so more memory. We have a certain limit onto how many you got. And this is like the maximum address. I can't remember what it should be. Like whatever, just maximum address. So all your functions and their local variables, when they execute, they get stored from the top down. And then if it's a function being called from the other function, it gets stored underneath. So local variables are here. So our stack allocated array is here. Over here is what we allocate on the heap, so I'll probably mark it as heap somewhere. And there's no like specific margin in there. It's literally just like some of the areas occupied by heap things, some of the areas occupied by stack objects, and then at some point they can meet, and that means you're literally out of memory because the stack is full, the heap is full, you got no memory. So the heap grows from bottom up usually, and stack grows from the top down. And anything we allocate of new, where you have it here, it goes on the heap. So our where's my text? So our heap allocator array is here. And then basically anything created with new. Oh, that's great. And basically when you create something with new, you get returned the memory address of where it was placed when it was created. And that memory address gets stored in a heap in a pointer. And that's what our heap allocator array is in terms of like the actual variable. The variable is just on the stack and contains an address pointing to the heap so that we can access stuff on the heap, and like the actual data will be on the heap. So the actual 99s, it'll be placed in the heap area. The address will be placed in the stack area. If you're okay with that. I'll save it somewhere, but it probably makes more sense for me speaking about it rather than just a picture and so. Yeah. So we're okay with this question. I print a lot of stuff here, but you're not really required to. You're just told to fix it, I think. Yeah. So it doesn't tell you to create a main function for it to test it, but I would just in case, just to see what's happening, because otherwise you don't know if it worked unless you're super certain in what you fixed. Also, if I put the plus plus here, we're gonna populate from index 1, because what we're doing is we're starting at the first index, like the 0th index, so we're starting here, the base address. We're going up by 1, and by 1 it means going up by the number of bytes needed to get over to the next integer, so it goes up by the 4 bytes to the next integer. That'll be this first element, and it sets it to the value, so it changes the pointer. Then what it does is dereferencing. Then we dereference to get the value at the pointer, and that would be like whatever is in the array at that pointer. And then we're setting to the value. So if I do this, this will not set the first element. And it'll also overrun it because I did not change the ending. If you look here, it did not set the first value this time because we incremented before setting it. So the first value we actually placed was here in the first element, element index 1, so second element. This indexing is really confusing, it's like wording. And basically we crashed because the size stayed the same, but we started one index later. So we actually shifted like past by 1, past the side of the array, and we can't access that area when we're in debug mode. So in debug mode it actually does the checks for you that you're not accessing like more than you should. But in release mode, when you enter release mode, it'll not put an error, but it'll actually modify some data that doesn't belong to the array. And that can cause issues because you could have needed that data to be a certain value. So see, this time it's all fine, it did not put an error. And you see how in debug mode all those values were the same before I allocated the array? That's because debug mode allows you to kind of see where like not allocated data is, but in release mode you don't know where data is like used and where data isn't used. I think we're okay with this. So I changed it back for it to work as intended. Start from index 0, set it, increment, and then all the way up to size. Next question. So we're given this code. We're told to make an IRA header file and put it there. I'll start to speed up a bit because I want to get to the harder questions, but feel free to stop me if you're not understanding something. And then Visual Studio puts the Pragma Once thing for you, which is basically the same as the header guard we do, but I would rather do the header guard because that's the way we're taught it in this module. So I paste it in, but then this means that when I include this header, if I include it here, this code here just gets pasted where this is. So this is done like before compilation, like preprocessor statement. That's what they call it. Like those with hashtag and then something after it are preprocessor statements. So this is done before compiling the code. So what it does is it just grabs the stuff from this file and then it just pastes it all here. Right. And then if I do it multiple times, it means I'm pasting it multiple times. So to prevent that, what we do is we do a header guard again with preprocessor statements because we need to protect it from duplication at the preprocessor level. So what we're doing is an if statement kind of, but it's like it's not in C++. It's in like a preprocessor commands sort of. If and def. So if not defined. And then if something is not defined, and this something is usually just the header name, just in all caps and underscore. IRH, that's how we do it. So if this is not defined, we do something. So what we do is we define it. So if it's not defined, it means it's the first include statement for this header in the CPP file. So what we need to do is we need to include the stuff in the header file. But then if it is defined, it means we don't do any of this, so we don't get duplication of the code. And you close it off in endif. So because there's no curly braces for those preprocessor statements, you have to have like an opening statement and a closing statement for the ifs. So if not defined, like just the name of the header file, sort of. Define the name, include the stuff, and then next time I put in like another one of those in, it skips it. It skips this part because this condition is not true anymore. That makes sense, right? All good. Answer me. Or maybe not, right? So this is the 2 marks. So you paste it in, and I think you need the header guards. Add source file. So we got the definitions for a class. We need to the declarations for a class. We need to put the definitions in. So we got functions, but they do nothing until we tell them what they do. So we create an IRA CPP file. I'm lost. Here it is. And then the CPP file, we include the header file to have access to this class. Then we can copy the stuff over. And it's usually just the functions you copy over, because only the functions you have to provide the implementation for. And then it doesn't know what those are because we need to specify those belong to this array class. So we take the array class, paste it in, and then the double colon, that's the scope resolution modifier. It basically tells that we're gonna change the constructor of this class, and we do that for each function. So if it'll just print on its own, that's just a function within the CPP file. It does not belong to the array. If we add this in, we're modifying the function of the class. I'm missing this. And same for fill, because we're modifying the fill function in the array class, not just some random fill function we're making. So, and then putting this in allows us to access the variables of the class, because now it's just a class function. So it's as if we were writing it here, but instead we're putting it in a separate file for this one to stay lightweight, so that when it gets pasted in here, it doesn't paste in all of this. It just pastes in the declarations, and then the linker will find the right function, the definition, when it needs to run. So when I call a function from the array in here, it'll go to the declaration, see what like parameters it takes, and then it'll find this function in like another file and use it from there. So we're told to overwrite, like write the code for the constructor, and the constructor is always just the same, named the same as the class, and doesn't have a return type. So you can put void here, but you didn't have to. Actually, I didn't like it, so don't put void there. Right. I mean, in Java you can put void for the constructor, but then it doesn't cause issues. So how do we make an array? We just grab the data pointer, that is a private variable, and we make it point to an array on the heap. So new int array of length, and then we can also set size is another local variable, class variable. So we can set the size of the array to be I need to read the question just in case, because I think I set it to length, but it's not. I mean, it is length though. Yeah. So the size of the array will be length, and then we instantiate it to the size. Right, and then this is a destructor, so it's just the same as a constructor with like a tilde sign, or wavy minus. And the only thing we need to delete in the destructor is probably the heap objects that this array contains. And the only heap object this array contains is this data pointer, because it was created with new, it was created on the heap, and we need to clean it up after when we're getting rid of this array. So what we're going to do is we're going to delete data, and because data is a pointer to an array, it's an int array, we use delete array instead of just normal delete, so that it goes for each element of the array on the heap and deletes the elements, because the elements can be also like heap allocated, so they can also be just pointers to another thing on the memory. And if we're deleting the array, we must also be deleting those objects on the heap as well. So this ensures that the destructor of each of the elements also gets called, not just the array gets deleted from memory. Does that make sense, right? So to print stuff, you got basically an array of data, and you got the size. So I can just grab the code from here because I'm lazy, and put it here. This will be data, and also we cannot print because we don't have IOStream included where cout is defined, and we need the std because I don't have the std before the cout. And the way I usually put it is I put like system libraries I'm using at the top, then I put headers I'm using from this project, and then I just put this kind of like, so like if I put more system libraries here, I can see that they're not, if I mix them in, I don't know which one is my libraries, which one is system libraries. So I just like separate it out like this. Fill. Fill is literally, what does fill do? Function to fill the array elements of random numbers between v0 and v1 inclusive. Alright. So to get random numbers, what we have is rand, and it's a function that basically returns you an integer, and it's an integer from like whatever, like 0 to like a huge number. It might be int max, so like the maximum value an int can hold, but I'm not sure about that. And then what you do to get better values out of it, the values you want in some range, you do a modulus operation on it, and you give it like a certain range, like 100. So what rand will give you is like whatever just value here. Then what you're doing is you're taking the modulus operation, which is basically divide and give me the remainder of the division by 100. And if you do that, what you'll have is 42, because 100 divides into that equally, and then you have a remainder of 42 left. And then like this number will obviously be different every time, providing you with different numbers, like 14 for this. And then I don't know, like if it is 0, if it is 100, would be 0. Like 1000, same thing. Right? So that's how you get value in a certain range. But this range is only from 0 to 99 because you can't get 100 as a remainder of division by 100, right? So it'll maximum thing you can get is 99. Because as soon as it becomes 500, it'll become 0 because it divides equally. Right? So to get this will basically give us values from 0 to 99 inclusive. What we can then do is we can shift it up. So we can add stuff on the end after it. Plus 10. And that'll basically increase this range by 10. So you're increasing each number in the range by 10. That'd be the new range. And if you know the maximum thing you want, which is like v1 for us, and the minimum thing we want, it's v0, what we need to do is make sure that for getting the value that is like between it's like the right amount, so that when we add v0 on the end, we can shift it up to be the minimum value. So so now it's from v0 to v0 plus 0, because that's the least this rand can give us, to v0 plus 99. That's the highest number this rand can give us, and then we're always adding v0 to it. That's our minimum value we want. So we got the minimum correct, just the maximum needs to be v2, v1. So this v0 plus whatever's in here needs to equal v1. So you can do like a mathematical formula to figure it out. I'll just give you the answer just to not delay your time anymore, because I think I'm wasting your time a bit. It'll be max, so v1 minus minimum, v0, and plus 1, because of this, as I was telling, like this will give you, even if the range is what we want, this will always give you one less than you need. So you can add 1 to get like v1, like to get the right range. There's plus 1. You can figure out, because if you just take this formula, you can figure out this from like what you need, from the range you need plus the offset you need. So this should give the right value for the value you want to fill in. And we're just taking this value here and we're putting it into each index of the array. So you can just grab their code. And instead of value, what we're going to use is this here, because it generates us the right values. Instead of PI, what we're using is data. So now if I want to test it in here, what I can do is I can create a new object of this class by using iArray. I don't know, just R1. And I'm creating on the heap because you see I'm not using the new keyword. So when I create an object on the heap, I call the constructor by using like the parentheses after the just the variable name, just the name I gave it, and given the constructor parameters in here. So what are the constructor parameters? Length, So I give it a certain length. I say 10. I might give 20 because I want a good, like, I want to see the range of values that this rand gives me. So what I'm going to do is I'm going to fill this array. So I can call its fill method. Give it minimum value, say 10 and 20. So I'm going to check that both 10 and 20 are present there, so we have an inclusive range of the random values generated. And then we're going to take AR1 and print it. So it's going to do the printing stuff that we did here in the console. Errors, good. Yeah, it has to be named main for it to run. And you also can't have like two functions named the same in the same file if they have the same parameters, so if they have the same like prototype. Got an error here. Shouldn't be an error though. There's sometimes an issue with if you have the same like name um, for the like the application class, like a source file, and in Visual Studio if you put a breakpoint in one of the same name, you can run into that breakpoint that is supposed to be in another file, but it executes in this file because they're named the same. So I'll have a look quickly if I put a breakpoint anywhere. I don't think I did. Must just be an error then. Try this. Does not like it. So we're going to print out what data is to see what it doesn't like, because it's unable to delete it for some reason, so we want to see what it is. Now there's confusion with what main function I'm using. So like the address looks okay to me, it's just it's not able to delete it. I was not planning to run into issues. I'll do some like random print here, so it's supposed to be trying to delete it, and it's like at the end here, and that's where it's going to. Yeah, so it got to line 81. It's trying to delete this array because it's not used anymore. Because when it goes out of scope, when it's a stack object and it just goes out of scope of the function it's contained in, it gets deleted. So the destructor gets called, and we're cleaning up some memory that we choose to clean up after this class. Yeah, I think no, it's a critical error. So I think it's not a breakpoint. I can check, yeah. In the Practice test. No, I don't think so. I do like null check it and when I did it, but then it's not null. When I print it, it's not 0, so that shouldn't be causing the issue. So that's like the address I'm printing here. And it's like a stack address. For some reason, it looks like a stack address. Because it's like sort of small. Oh, maybe no. Should be a heap address. Kind of stuck here. Like, even if you're like stuck like that, you can still get marks for the working function. So it's literally, if it's literally just this destructor function that's not working, you can leave it out for now and then come back to it if you have more time at the end. So I'll try to come back to it and fix it, and then I'll explain what's wrong with it. I've got no ideas for now, so I'm going to leave it out. But then we can literally test every other function. It's just that we cannot test the destructor because it doesn't work. Does it print? Oh, it doesn't print. So what I have here, I got it to print, and it prints if all zeros. Then I have it to fill, and it's supposed to print again, but it's not. Maybe something wrong with the print function. Doesn't look like it. It's weird stuff. Right, I'll come back to this question, and I'll try to fix it at the end, okay? I want to get to the next question of templates first. There's something weird going on, I'm not sure. I even just trying to restart Visual Studio could be helpful. But if not, I'll just go to the next template question. Like for the most part, like the code should work. It's just like something going really wrong with the object.
Is this practice video?
Yep, it is. And the thing that's going on is in release mode as well, because I forgot to switch from back to debug mode. So if I go back to debug mode, I might get more info. I was in release mode to show you that like you don't get like index out of bounds exceptions in release mode. So if we go on the stack, line 81, for some reason it just doesn't print. Like the second time it's supposed to print. Because I called print twice and it only prints once. Weird shit going on. Something just has to go wrong, right? the size is okay, at least. Right, no clues for now. I'll come back to it. The next one is a template one. And it's asking us to convert the fill function in project 1B, so this one, into a template function and put it into test to CPP. So to create a template, you write template and then the angular brackets type name and give it some name, usually put T down. And then anything you want to replace with a templated parameter. So anything you think is going to change the parameter type, you're going to replace with T. So I'm going to think we can pass different types of arrays in. I'm going to change it from int to T to be able to replace it with different types. And also the value you put in, because arrays are of a different type, the value will be of a different type as well that we put in. But the size will probably stay integer. So that's how you make it templated. Now we could probably test it, but it's not asking us, but I'll test it quickly. And now we can replace it with, I did not see fill. It used to be const size, because remember it's a stack allocated array, so it needs a constant size. You can make this a char type, and this is a char. I can cut this to a char. It'll probably get casted as it enters the function, because basically this will replace this to char. Or will it? No, it won't. So I can cast it then. So this needs to be char, and this needs to be char, and this needs to be int. So I'm kind of forcing the integer to become a char type for casting. And then you can use it with string as well. Just need to include some stuff to be able to print stuff. And also I want to print the stuff out. hover over it, it tells me it doesn't like that what I'm passing into this function is a string array, an integer, and then a constant char of length 4, constant char array of length 4. So it's considering this a constant char array instead of a string, but like this template tells those two to be the same type, so they both has to be string. So if I pass in a string array, this needs to be a string, and basically to convert it to a string, use just a string method. Because if you just have it as speech marks like this, and you use it as an argument, it's interpreted as a constant char pointer, or a constant char array. So it's like an array of characters, rather than a string, which is like a class. So you make it a class by using this function. I must have got some lucky character because so first one works, fill it in with tens, the array gets filled with tens. The next one, the characters, it fills in with something that literally goes on a new line every time. So it fills in with /n, must have guessed the value somehow. So 10 must be just /n, which makes it in the print, it makes it go on a new value when I print it, a new line when I print it. And then the last one, ABC, I fill it with ABC strings. If I change this to like whatever. And it just fills it with chars, different chars. It was just /n it filled it in with last time. So that's for this question. I think it's alright. Yeah, so just template it and then test it if you want to, but you're not asked to test it. I would test it just in case if I have time. Now create a new main method. So I can probably rename this main1. Because I'm lazy, I'm going to copy and paste this. And what we're asked to do... Oh, I skipped this part. So take this, add a header file, paste this into the header file, and then convert this from an integer to a templated class in the header file. So we add a new header file. Two values, it is called. Two values at age. Paste it in, and then the header guards. If and if not defined, two values h. I choose this name myself, I can name it forever. We're going to define it. And here we're going to end the if. So now this class should work. Just we have to change it to a templated class, and to do that, before the class and whatever name it is, we put template type name t. Then we replace whatever is supposed to be a different type with t. So instead of int, it can take any type here. It can take the same type here. And then the data stores, both of them will be of type t. The two values is another constructor. Or it is just definition of the constructor. But put in t here, and that's okay. And now here, it doesn't know what type t is because you need to copy and paste this before the function name when you define it. What do you not like? Seems alright to me. Alright. This. So when you make it a templated class, scope resolution modifier also needs this templated look for it. So what you're doing is you're defining what the equal function will do for the class toTypes, templated by type T. And for it to know what T is, you need to include this before it. Otherwise, like if I remove it, or I remove it here, it'll not like this T here. So you need to tell it that it's like some type that you're going to be templating, that you're going to replace when you actually execute the function. You're going to replace this with the type you want to use. So that looks okay. And then I think we can just test it in here. It probably tells us how to. So create a main function, create a toValues object with two double precision values. So to use the two values, we need to include it here. That's what it's asking us to do first. Just declare an object with two values. So we pass in double because double is what we're going to use in the class. Call the equal function. So we're grabbing the object name and calling its functions, and it suggests us what functions it has. Next step, if the function returns true, print this message out. We're going to do cout print the message. And this equal function always returns us a boolean. So we can use that boolean in an if statement. So if the result of that function is true, what we're going to do is print out this message. Otherwise nothing happens. So if this returns false, it just skips this line entirely. Now we do the same for a dynamically allocated toValues, but this time it's going to be of a string type, and it's going to have the two values A, B, C, D. So put string here. It's okay with that. Call the equal function if it returns true. Oh wait, I forgot. So this says dynamically allocated. So again, we're allocating the heap using the new keyword. So it's going to return a pointer, and you're going to use new, call the constructor, pass in the parameters, and it returns a pointer. And because we're returning a pointer to the heap, we'll need to delete the pointer at the end, or delete the stuff at the pointer at the end to clean up the memory. And then because it's a pointer, it doesn't use a dot, it uses a arrow operator to call the function. That's okay. Free up the memory, and I've just done that. I've deleted the pair, and I don't use delete array because it's not an array for the most part. Yeah, I think. I think that's this question. Write a template function bool allocate. So what it does is dynamically allocates an array of type T size elements, and then it fills it with the value of type t as well. Provided type t. So it's a Boolean return, so if it was successful it returns true. If it wasn't successful to allocate the array, it returns false. So we try to allocate on the heap an array of type t and size of size elements, because we get the size passed in. Then if the allocation didn't happen, if it wasn't able to create an array on the heap, it'll basically return null or 0. So if no allocation occurred, null is returned. PT is null. And null is basically what null is in reality is it's literally a define, so you do hashtag define null 0. And what it does is basically everywhere it sees null, it will replace it with 0 in the actual code. So when you see null, just think of 0. That's like the 0 address, and it's like an error address. So nothing can be at address 0. So if something is at address 0, it means it's not allocated. So it means we have to get rid of it. So then we're told to return false if we couldn't allocate. So what we're going to do is compare it to null, or compare it to 0, same thing, or null pointer, null PTR, all the same. And we're going to return false. If we were able to allocate it, we're going to fill it in with those values, and we already got a fill method we can probably use, so just grab that. Pass in the pointer, pass in the size, pass in the value, and then return true. Because if we were able to allocate it, we can fill it and we say it's done correctly, we can return true. And again, it doesn't ask us to test it at the end, it just goes to the next topic. But I will test it just in case. So do it with an int array. I'll probably grab this code from here. Oh, actually, it'll be because it's heap allocated. It needs to be an int pointer. We pass the pointer to the function. It allocates stuff in the heap and returns the address into that pointer and stores it there. Am I still recording? Yeah, I am. So I can declare the pointers of different types beforehand. So to free, just do free. I think free is enough to test a template, so just int char and string. You can add double in there if you want to as well. Double and float, whatever, but usually that's enough to test it. I will make them all the same size. What we're passing in each of those pointers in order, passing the size, and then passing in a value of the right type for this pointer. For an int, it'd be, I don't know, 99. For a char, it'd be a char of 99. It is a B, I think, because, no, C. 97 is an A, 98 is a B in ASCII code. And then for string, alright, and then we can probably print each one. And it all works. It's all good. Now just remember anything you created with new in here, because we created those with new on the heap. We probably want to clean up after, so we're going to delete them all. So delete array, because this time it is an array. Delete array, delete array. It's all good. But then again, like this main method is not marked. So if you feel like you're running low on time, don't do the checks, just do the code for the marked parts. Stacks now. So we're asked to copy some of the code, some of the files into a new project. I've got the files in another project, so I'll just reference them. Kind of this one. I'll just like re-download them, I think, from Canvas. Should have prepared for that. Where are you at? Should not have closed this. Then I always do copy and paste the main method. And now those files need to go, the stack files need to go into this project. So this one here. I can open it and drag and drop them over. Then I need to find them and add them to the project in this view. Add existing this time, so we're not adding new ones, we're adding existing files. Header. This one. And now here we need to include the stack one, so stack.h. And there's certain stuff we need to do with it. Here right now. So dynamically allocate an empty stack for pointer PSA. So PSA is going to be an empty stack, so it'll be stack. And I think the stack thing is templated. You see, yeah, it is. It's a templated class. So what type do we want? Storing characters. So char type. Dynamically allocate. So it's going to be pointer, and we're going to use new. Next, push 26 letters onto it. And we're given the ASCII code so that we can use chars and we know which chars we need to use. So a for loop from the chars they give us, so 97 to 122, and that'll be inclusive, so from I equals 97, so I is less than 122 plus 1, or just 123. I'll leave it like this, or just do less than or equal to for it to be included, for the 122 to be used, to be last value used. What we're going to do is we're going to use the push method on the stack, in the stack class, to push the character. So I can make this character instead of int. So take the object, I'm too lazy. PSA is a pointer, so to call its methods, to call the objects of the methods it points to, we use the arrow operator, and we can use push from the object it points to and pass in this I. And then print the stack content. So again, PSA print, and has a print method in it. Here, this one. So we run it just to see. So A got pushed first, so it's at the bottom. Then B got pushed, and C got pushed, and D. And basically the last one got pushed is Z. And the way it prints it is it prints it from last one pushed to the first one pushed. Because it's like a last in, first out structure, so the last one in is at the top to be accessed more easily. Print out the position of character M in the stack. So basically this exercise, it make sure that you can look at this stack, see what methods it has, and see how you can use them to do the exercise. So this time it tells you to like print the position of M. I mean, you can just print it if you just calculate it from like 97 to 122, which one is M. No, sorry, which one is M in the alphabet, just like the number. But instead you can just call the method from PSA called search, which takes in like a key, so like the thing you're searching for, and returns the int, which will be the index of the thing, and the search method is here. So you start at the top of the stack, which is going to be a node on the heap holding a certain value, and it's going to point to other nodes on the heap, and that's how like all the data is linked up. So it starts at the last position on the stack and goes until it gets to 0. So if it gets to 0 and still hasn't found the thing we're searching for, it then will return -1 because it's not in the stack, so the position is -1. Otherwise, if the thing we're looking at has an item, which is the same as the key, we return the position we're at. Probably -1 because of the way they did it. Because they started at stack size, which is like one more than the actual index. And then if each time they go down, there's still one more than the actual index, so they need to remove 1 when they return the position. And then with each iteration, what they do is they go from this node to the next node by accessing its member, member variable that points to another node on the heap. If that's okay for you. Right. So PSA search. I'm looking for M. And it's 11, which is like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Alright, right. I guess it starts indexing from 1, so does it say that? Doesn't really, but I guess it indexes from 1 for the thing it returns from that search function. So if I look for Z, for A, it doesn't find it all. That's weird. I mean, that's their code, so it should be working. If I try to remove this, let's see what it gives us. 0, right? I think this -1 is wrong in their code. We should now tell Jai about it. So like this time M will be 11 as I counted it, or like 10, 12, fuck, whatever. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, and that's what we got. And then by taking -1, they made it go by 1 less, and then A became at index -1, which is probably wrong. So that's this. What's next? Print out the position. I got this. Allocate a new stack object dynamically with a pointer PSB, and then we're going to copy the stack PSA into PSB. So to do that, we covered copy constructors, and this class defines a normal constructor with just no parameters and a copy constructor, and it's even got comments for you so that you can look for it. So what this copy constructor does is it takes another stack object, not a pointer, and then copies the data over into the stack you're creating. I can look at it now here. So it grabs that other stack object, grabs its like first node, the top node on the stack, and basically pushes it onto this basically, because when you, if I draw another diagram of copying a stack, so imagine the stack is like, I don't know, a cup, and there's stuff on it. You just drop stuff in it, and you can only access the top thing in it. I could probably make some different colors. Go with 4. So what's going to happen is they're grabbing the top one on the stack they're copying. They're taking its value, so they're not actually taking it off the first stack, they're leaving it there, but they're copying its value, and they're pushing it onto here. So that it drops to the bottom. It's going to look like this. Then again, grabbing this, and then it drops to the bottom. I'll just draw it out. And same for green, same for, it should have been orange. Then green, and then red. But then what we have is not a copy of the stack because the items are ordered differently. It's actually reversed. So the trick they do is they copy it again to another stack, which will be the final stack we stay with. So if you look now, red gets pushed first, goes to the bottom, and then green, orange, blue. So now this one is this copy stack, stack for copying. This one is like the intermediate or like temp stack, temporary stack. And then this one is our final stack, the stack we want to have. That's the trick there. Let's save this as well. So now I just told you how they copy the stack. So now what we're going to do is we're going to create a new stack, PSB of the same type, I think. They mention it. They don't really mention it the same type, but because we have to copy the contents, it has to be the same type. It's dynamically allocated, so it'll equal to a new. And then what we're doing is instead of calling the empty constructor, which will make us an empty stack, we're calling the copy constructor to copy a different stack. So what you're doing is you're calling it with the parameter of a stack. So what we need to input here is a reference to a stack object, and it's a constant reference, which means we cannot change the object itself, but we're like passing it by reference so that we're not like copying the object data into a local variable. It's just a bit more efficient to reference it than to copy it onto like a new like local variable. If like a local variable here of like the stack type is basically the only reason this is the reference. Pretty sure. So what we need to do is we need to pass in PSA, but PSA is a pointer to the object. But we need to pass in like the stack char object, not the pointer. So what we're going to do is we're going to dereference a pointer to access the object. That's okay. And then print the content of the second stack. So just print PSB. Just get a nicer print going quickly. Yeah, so first stack, and then second stack is the same, and it's ordered in the same way because of the like the double stack thing I showed you, that with the temporary stack in between to flip it. Yeah, free the memory, right? good that it reminds you of it, because it could be not mentioned, but then there could be hidden marks for freeing the memory of the pointers. So because we made 2 pointers and allocate them on the heap, delete them. Delete 1, delete 2. Uh, I mean, you could make a pointer pointing, like in the very first example it is like an integer c, and then you make an int pointer pc. Like I'm gonna reference this pointer, it points to the stack, right? Because c is on the stack and we're pointing to c with this. You don't need to delete this pointer because it'll just go out of scope, just like c will go out of scope. But then if you're using u, you're putting stuff on the heap memory. So if I load up this again, and like in C++, there's no means to clean up heap memory for the computer. So anything that goes on the heap has to be deleted at some point, or at least during the running of the program. If you don't need it, it has to be deleted. Because if you run a new program after that, it'll pretend like the heap is empty, and then it'll just override the stuff that was there from the previous program, so it usually doesn't cause an error. But like during the running of the program, if you want to clean up the memory, you need to delete stuff that went onto the heap. So anything that was created with new will eventually have to be deleted. Just for like a stack, it has to be deleted when the stack gets deleted. So it's all the deletion occurs in the destructor. So when you call delete on the PSA or PSB, it basically goes and deletes like whatever's at this memory address, but also it calls the destructor of the class and looks for whatever nodes it had and deletes the nodes as well, because the nodes can be like all over the memory. So if I know, do you want a diagram or not? Basically, because the nodes can be scattered all over the memory depending on how it's fragmented. So depending on like what spaces were available to put a new node in, to create a new node. So next thing, grab the code. So here it'll be just like some sentence you put in, and then the input just grabs words from it. Probably need a new main function. What does it want us to complete? Okay, so rename main to main1, modify the program in test3. In the program, use another stack, send2, to reverse the words stored in send1. So send1 here is a stack. They ask the user to enter a sentence ending with a dot. So they're going to enter like a bunch of words, and the words get stored onto the stack one by one. So when they're printed, the first word is at the bottom, the last word is at the top. So when you start printing it, it prints from top to bottom. So it's going to print it in reverse, and what they want is first to print it in the correct order. So what you need to do is to reverse this stack using a different stack so that the order is correct with enter on the top, so it gets printed first. So I do this right now and ask for just a sentence. Even gave like an example of what we can use, test it. This is a test, and then dot. So this space is space a space test, and you need the spaces for it to distinguish between like separate words, and then it reads the dot as a separate word and knows to stop at the dot, because when the word is a dot, it breaks the while loop. And you see it grabs the words and puts them in reverse, because I said that's the way it puts it on the stack. So last in, first out. So what they want us to do is to make stack2. And you see the way it's the stack is stack allocated. So it's not allocated on the heap. We don't need to delete it because it'll go out of scope with this main function, deleting itself and deleting the nodes it uses using the destructor. Well, stack is kind of limited, so you don't. If you want to store something large, you put it on the heap. You don't want to fill the stack with a lot of data. So if you got like a lot of objects, put them on the heap. Usually. Not sure. See, I'm struggling now, but I'm also explaining at the same time. So if I was like head down coding, I'd say it is quite tight on time. But potentially, if you understand it all, like you will not have problems if finishing in time.
I say it'd be tight on time to finish. Most people.
Like I say, like I'm running out of time right now. Like I started, wait, 3 hours? How long am I doing this? When did I start?
You started Tuesday.
Yeah, so I've got this one to finish, and let's say if I finish this one like in the next half an hour, I've still got 45 minutes to finish this last one, but I still have to fix that thing that was going wrong for me. I've got no clue what was going wrong here with this destructor.
You just look at marks.
Yeah, sure. Like that's what Jai was saying. They'll mark the logic, and if it doesn't compile, they'll try to mark the logic. Just try your best.
And if you get stuck, just remember, you're supposed to do.
Yeah. Just like all. Oh, what? It got screwed up. It's in class. Was it? Yeah. So basically, for the most part of the first section, it went fine, right? Just do that, do the fill function. Then you're told to copy this into a header, and I copied this into a header. Where's the header? Header. Add the header guards like this, and then the implementation. And then basically what goes wrong is when I run it, it runs this main function. So just create an array of size 20, print it, fill it with there's like a function to fill it with a random value from like whatever, like max to min, and then I print again. But then it prints it the first time and then tries to delete it at some point. I might put a breakpoint here, I think. I would actually run to the breakpoint this time. Okay, weird. Basically, last time I crashed at this point before here, and it was like, I don't know, just some error in the destructor. So some error in here, literally on this line when trying to delete data. And I have like very little control of that, because that's like whatever the computer decides to do when it's deleting. I think when you're deleting an array, because data is an array, you usually go for this, even though it literally does nothing in this case, because it's an integer array. If it's an array of other objects allocated on the heap, you do delete array to make sure those other objects get their destructor called when the array gets deleted. That's the whole point. Let me try to run. It might have fixed itself somehow, so I'll try to run it. No, it didn't. Call stack, and yeah, that's the issue here. And then I print whatever data is, and data is like a normal like address, so it should be able to delete at the address. This does not change it as far as I remember. I'll like try to fix it in my own time to not like keep anyone back. I want to finish this practical. Oh, I probably can't in the time. It doesn't work either way. Oof. I'll try to fix it in my own time. I'll not spend your time trying to fix it. Like, it's not even the main part of the program, it's like literally the very last thing that happens in it. So I doubt you lose many marks for it. So we're reversing this stack, and to reverse the stack, as I showed this picture here, we can just push from the top of the stack onto this new stack, and it'll literally get reversed. So that's what I'm going to do. So from 0 to size of the first stack, just iterate the number of times of the elements in the first stack. And just have a size function. It does. Or does it? Oh. If it was underlined, then all of a sudden it's gone. That's what I like to see. So what we're going to do is we're going to push onto stack 2 whatever we pop from stack 1. And I think we don't care that we're actually removing stuff from stack 1 because we don't actually need it. And then instead of printing stack 1, we're going to print stack 2 because it should be in the right order. Oof, that did not work. What happened here? That should have worked. And dot. Skips the first two somehow. Oh, right. The hell's wrong? Do it a different way. So the size of the first one's going to change every time, and when we get to size of 0, we know we popped all the stuff off it. So while it's greater than 0, we're going to keep popping stuff off it and pushing it onto this second stack. And then it works. I'm sure I was wrong the first time. It's literally pretty much the same code. But I think this one makes more sense, and I guess it works. So I'm going to leave it like this. First one should have worked though. Yes, if it's a single line and it's like a for loop, so for whatever, you can do like one line, and same for an if. So like in a function, do like if like whatever object you passed in equals null, you'll just like return false or something, or like return from the function. It's like a, I can remember some guard clause it's called. So like if it's just one statement, you can do it without curlies. If it's more than one, you have to use curly braces, and everything gets screwed. If you're formatting screwed, just do Control K, Control D. And that should fix it up a bit. And now, still got one more. Need to implement 2 functions on the stack. I'll try to do at least one of them in the 5 minutes I've got remaining. And then if anyone needs to leave, they can leave. They're free to leave at any time though. So we go back to the stack and we're told to add two methods. So I first declare them here in public methods, which are int count and int insert, but I didn't have an insert. And we're counting the number of times we got an element t in it, item t. And then same for the boolean here. Insert at a certain index, a certain value. So we declared them, now we define them just somewhere near the bottom. It's a templated function because the type t item. We also need the scope resolution modifier. And then it doesn't like that we don't have a body for it, or it does. It usually doesn't. I guess in the header is fine. So basically for count, if it's not in there, we're going to return -1. Otherwise we're going to count it and return it. So the stack, the way the stack works, it creates nodes on the heap and like links them up with a pointer in one node to the other node. So, and it stores the very last node it added in this variable here, ptos, so pointer to the top of the stack, which will be a stack node pointer, pointing to a heap allocated stack node. So you can grab this p top of stack and because we don't want to actually change the top of what the top of stack points to, I'll create like a local variable, stack node of type t pointer, and call it temp. And it's basically like the temporary pointer we're going to use to cycle through all the pointers, all the nodes of the stack. Because I want this to stay pointing to the very top one. I don't want to make changes to it. So I'm just going to copy it into like a local variable I can use. So while we're not at the end, which will be null, because basically if there's no items in here, or if we get to the very last item, there's no item after it, and it'll point to null. I'm trying to find. So if a stack is empty, top of stack points to null. If we add another thing, a top of stack will point to like a node, but then that node will point to null, so the previous value before it, because it was null. So if I find push, so the new node gets created, and in the constructor it points to the previous top of stack, and then top of stack gets reassigned to the new node. And because it started off as null, it'll point to null if it's the very last node. So when temp is null, we stop iterating and return -1 because we didn't find the value yet. Oh wait, wait, need an integer for count equal to 0. If the value at temp, so temp is a node and it's a pointer, so we need the pointer operator to access its variables, and has item. So if you go into stack node, it has an item where it stores the actual data in the node. So if we access that data and we compare it to the item we're looking for, and it's the same, we're just going to increment count. So we're going to return count then. And Then what we're going to do is we're going to grab the temp and make it equal the next node along, so the next node points to. And then when temp becomes null, so when we get the last node and get the next node points to, which is null, we stop, because we checked the last node. We went to the null node, which is the very beginning, and we need to stop. And basically, to return we need to return -1 if we didn't find, if the count is 0, probably. Oh wait, we don't need to actually. I'm being dumb. So yeah, literally if there's if there's no element, no such elements in the stack, it returns 0. So if it started off as 0, if it didn't find any, it will not increment it, so it'll return 0 at the end. Right. And then also, it doesn't tell you to test the function in the main method, so I'll not do it for now. No, I can do it at the end when I get this one to work as well. Insert node, insert an item at position n, and tells you position, indexing of the position starts at 0 for the very bottom, and then like it'll be size -1 for the very top. Let's see. So straight away, you know that if n is equal to size, and so if you want to insert at the position of size, it's literally the same as pushing. Because imagine you got like a stack. Oh wait, you push the item. I'll draw it quickly. So you say I've got some items on the stack. I'll just draw the indices. 0, 1, 2, 3 should be enough. So the size of the stack is going to be 4, but there's going to be 0, 1, 2, 3 as indices. So if we want to push, if we want to insert at position 4, that's the same as inserting here, where there's nothing right now, so we can literally just push it onto the end. If we want to insert at position 0, that's the same as like grabbing 0, making it point to a new node, and making that node point to null, because that's the bottom, because I say got null pointing here. And basically, if so, n can't be less than 0. So if n is less than 0, or n is greater than size, we return false. Then what we can do is we can create this new node with this item. So stack node type t pointer. And why we want to make it as on the heap is because we want it to last longer than this function. So we want to create it and leave it on the heap. Otherwise, if we just make it on the stack, new node, it'll get deleted as soon as this function ends. But we want to keep it. So if I create it like this, and then what does new node take? It takes a value item and takes a pointer. Probably do it here, because if we're pushing, we don't need to create a new node, but if we're not pushing, we do need to create a new node to link it up. So we're creating a new node. So we're going to start at the top. So again, just use a temp. I call everything temp, unfortunately. Which will be top of stack, so we start at the top. And then we look if it's the value we're supposed to insert at. So if, we'll probably need a counter for the position we're at. So position will equal size minus 1, because that's the position of the top of stack. Because remember, the 0, 1, 2, 3, top of stack is at 3, size is 4, so 4 minus 1 is 3. And basically, while position doesn't equal n, and n is the position we want to insert at, what we're going to do is we're going to go to the next node. So temp equals temp next node. Alright, and then what we're doing is it's literally going to stop at the right node, and we already checked for some edge cases, so it cannot go past the end. So it'll always, like in this else case, it'll always find the right node, because the node will be within like the range of the stack. So n will be within the range of the size of the stack from 0 to size. So now to insert, to link this node up, what we're grabbing is this node. Alright. With each node we go down, we are going to decrease position. So we start at the top and we go down. So now temp is the node we want to be at. So 0, 1, 2, 3. And we want, let's say we want to insert at 2. So we start at 3, we go down, so we're at 2 now, and we decrease position to 2. Then next one down, we check the condition. Position is at 2, we can stop. So now the temp is pointing to this node here, the one we want to insert. I think you insert after it. It doesn't really say, but like usually the way insert works, you insert after it. So now this becomes 2, it becomes 3, this becomes 4. So we're going to insert here. So we're going to make this node now point, instead it was pointing to 1, we're going to make it point to our new node. And we're going to make our new node point to 1. So we're creating a new node that'll point to 1, and we can get the pointer to 1 from temp, because temp right now is 2, it already points to 1, so we can get where it points to. So now a new node will point to 1, and then we can reassign temp to point to 2, to the thing we insert. Next node, pnext node. Give me a hint. Alright. I like autocompletes. And then temp pnext node is going to point to our new node now. Does that make sense? Okay. Hopefully. Oh, also, if we are making a new node and we're not able to create it, so if new node equals null, if it wasn't able to create a new node on the heap, we're going to return false. Double equals. That's this question, and we can probably test it quickly. I think I'll not keep you to do this question. I've already sent my answers for it, and it should be working as intended for the list question. Well, I'll not show it, I guess. I'll just get this tested. No, that'll be me, I think. Where's that? So we got a stack. And what if I was retesting again? Count and insert. I'll quickly copy from the one I did when I was doing it, just to save some time. Where's that? Stack. So to test it, what I did, I put a bunch of values in. I actually inserted them. And then, so I created a stack, pushed values 0 to 9 in, and then did a bunch of inserts and a bunch of counts. So we're pushing values 0 to 9, an integer stack, and then just doing a bunch of inserts. So lost. So I'll do this one by one for the tests. Great. Alright, so see where I use size? It's not called size. It is called stack size. Or instead I could use a size function with the same effect, because that's what it returns stack size. So wherever I use size here, it's complaining stack size. That should fix some of the issues at least, but not all of them, apparently. I did this by accident. Try again. So okay, so first what I did, I pushed values 0, 1, 2, 3, 4 up to 9, and then I insert at 10 the value 99. So at 10 is at size, so that goes to the first if in here, or the second if. So if n is equal to the stack size, we just push onto the end. If otherwise, what we do is we do the insert of the nodes and linking up the nodes. So I'll do another. So at -1, it should do nothing. So again, nothing, it doesn't insert anywhere. At 0, it'll insert at 0, make 0 point to the new node, make the new node point to null, which 0 used to point to. At 5, I'll probably comment this out. So at 5, it inserts where 5 used to be. So now 5 points to our new node. Our new node points to where 5 used to point. And then I put 10 here because I actually had them all running at the same time, so 10 would actually be within their stack by the point I inserted a bunch of stuff. And then to test the search function, because I inserted a bunch of 99s, I can just print the result of the search, the count function. Where's it up? This thing. So what I'm doing is counting 99 in the stack and then printing it. Tim, why are you spamming me? So there's it. I inserted a bunch of 99s. There's 4 in the stack, and the count function returns 4. So if I didn't do a bunch of this and tried to count 99, it should return 0. If I just pushed 199, it'll be 1. So that all works. I don't know if you guys want to stay to see the very last example. It's up to you. I got time to show it. Alright. lists. I think it's kind of a long one, or is it? Oh, it's not really. So again, in the lists project, drag and drop those. And then add them in. Existing item. This and we're including list.h to this, and the main function. It's asking us. Okay, create an empty list object for storing integers. So again, if you look at the list, it's a templated class. So it's called just list for integers. I think it tells us to name it like that, does it? Yeah, object L list. Maybe it's an I, got no clue. Insert 10 any range numbers into the list. So a for loop. We're gonna push. List doesn't have push. What does list have? List has insert front, insert end, insert. So we're always gonna insert at the end, I guess. Same as pushing. So insert and an integer, which will be just random in the range of 0 to 100. So it'll be values from 0 to 99 inclusive. That should be fine. Insert number 1024 at position 4. So we can look at the list. It already has an insert method for a certain position. So we're going to use this one now. So give it position, give it the item. So list insert 4 1024 and print numbers first to last by calling the get function. So the list does have print, but we're told to use the get function and print it ourselves. So we can't just call print to do it. So what we're going to do is we can get the size of the new list, because list has a size method. Where is it up? Size. So we can iterate the number of times we need for each element. I is less than L list dot size I plus plus. And what we do is we print the element of L list by getting it at the index of I. I'm not sure, it doesn't want a new line, doesn't want space, doesn't really say how it wants to print it. So I'm just gonna add a space between each one. And then /m to get a new line going. As for this one, we can try to run it. So we got some random values, and it inserted 1024 at position 4, so 0, 1, 2, 3, and 4. So at position 4 it inserted it and shifted the rest of it to the right, or like whichever way. And then the next task is to perform the same action by calling getNext. So the way getNext works is sort of weird. Basically, there's this pointer, a member variable called current node, and getNext shifts this pointer to the next element. And there's also functions to set p to a certain position, set p to the first position, set p to the last position. So to get and getNext, I think always shifts to the right. So it needs to start at the front and then go to the end. It's like first to last position. GetPrevious goes back. So you can start at the back and go left. So you can set the pointer of pCurrent node, just pCurrent node, to the first position using this here. Set p first, which literally does that. pCurrent node equals first node. And then we're going to use getNext to shift the position of the pCurrent node and also return the item at that position. So again, just can do the same for loop. Just before starting, we do ls.set p first. So we're setting current node to the first position. And then what we're doing is getNext just because it doesn't take an index. And basically, getNext, it returns you the value at the position of the current node, and only then it shifts it. So we're not skipping the first one. Otherwise, if it shifted and then printed and then returned, we would actually skip the first node. It's just the same result. So what set p does, it tells the current pointer to point here. Then every time we do getNext, we're returning 41, but also shifting the pointer to this. Next time we call it, we're returning 67, telling the pointer to shift next, then 34 and so on, basically until we get to the end. This is all fine. Some program that gets a bunch of characters, and then you mark the end of the string of characters with the hashtag. Right, and what does it want us to do? Rename the above main to main1, rewrite program by using linked list to replace char array. So we want to replace or reuse char array with a linked list to perform the same operations. So let's start from the top. We're going to replace this with a char array, with a linked list, sorry. So it's going to be a list of characters, because that's what we're going to be inputting here and storing. So type characters to store. To see what to call it. I don't really. Call it list again. Linked list. And what we're going to do with each character is push it onto the linked list, and then we don't have a neat size. So instead of push, it's called, for a linked list, it's just called insert end. So on the end, we're going to insert ch, which is basically the character read each time in the while loop. Then it'll be linked list.size. It'll be linked list, and we can use this thing here. So to getNext, and the set first to just print it. And we don't need to delete anything because I made a stack allocated. And it does not tell me to make it dynamically allocated, does it? Doesn't really. But I might as well, because it tells you to basically replace the char array with a linked list. But char is stack heap allocated. So it was allocated with new and then deleted. So I'll do the same for linked list for it to kind of be like a valid replacement. So I'm not like reinterpreting it. So create a new, and also because it's now a pointer, I use a pointer operator for accessing methods and variables instead of dot, just this. So minus greater than, and also just delete at the end. Delete list. Okay. So just that's basically all it does. It inserts them and then it just stores them onto this list and prints them back. I think that worked fine. And then it wants us to write two methods in here. So one method that provided a linked list. So basically print in reverse linked list. So grab that, put it into list, just at the bottom somewhere. And then define what it does. The scope resolution modifier. So to print something in return, in reverse, what you can do is you can move the current pointer, current node pointer, this one here, to the last node, to point to the last node using set p last. That's what it does. Current pointer equals last node, and then use get previous to shift the pointer downwards the required number of times. So basically, I'll use a for loop, and we want to print like n elements, and n is going to be size. So int I equals, and I can call the size method of this object to get its size, or I can look at does have a size thing. Probably doesn't. Oh, it does list size. So if it's within a class, I prefer to use a variable for it, like the class variable for it, instead of a function that returns that class variable. May not necessarily be better. So before starting to iterate, I do set p last. Then I do print get previous, get prev, space, and then new line. So it'll set p to be the last one. I'll print it and then I'll explain it. Just give it some random letters. Alright, I'm not testing it because I need to create another main. And I'll just copy this whole thing, and then instead of just this print thing, I'm gonna use print underscore r, because that's the method we just made. and it prints them in return. So what it does is first it pushes, obviously, it like puts all those on the list. So first this and this and this, adds them all on, right? And then what I'm doing is I'm setting current node pointer to here, and then doing get previous. So get previous will return this and shift the pointer. So we returned G and printed it, shifted the pointer, return this and print the shift the pointer, return E, shift the pointer right, and say, like return D, shift the pointer to C, return C, shift the pointer to B, return B, and like just so on. And we do it like a correct number of times to make it work. So this one is like easy enough if you understand what methods are in list class. And like they'll obviously provide like a similar list class to us in the test. They can't like change it a lot. It might even be simpler without those set P's and set first. And then the last question. So we want a template function inside of test CVP. That's what I'm doing now. Just paste it. Or rename this. And it's gonna search searches for the last occurrence of the item on the list and returns the index, the position of the last occurrence. So the position starting from 0 to like size -1, or -1 if the item is not on the list. So we're taking the list and once again we can start from the end because we're looking for the last position, and this literally will be the first position we meet from the end. So if we again set the pointer to the very last node and start working backwards, as soon as we meet it, that'll be the last position of the thing we're looking for. Now the question is, when do we stop? I mean, we can just iterate the number of times the length of ls. So again, just a for loop like this. Only this time it's called lst. So we're going to go for each element by getting the lst.getPrevious. And then if lst.getPrevious equals what we're looking for, we're going to return the position, and the position will be well, lst.size -1 minus I. Or instead of doing this weird thing, we can literally just make I always be the same as the position we're looking at. So we can start at lst size -1, make it go down to or equal to 0, and we're gonna, instead of increment, we're gonna decrease. So that's like a reversed for loop. So start from the top position, go down to 0 by decreasing I, and it's size -1 because that's the very last position, considering that the first position is 0 indexing. So now we can just return I here. If we didn't find it, we return -1. And now to test it, I'll just use the same thing again. So I'm gonna print the list, and we're gonna search for, I don't know, D. It's not like, okay, it's not part of the list method. It's a separate method in this class, in this file. So we pass in the list and we pass in the thing we're looking for, and it uses the list to find the thing. list and then D. But because list is a pointer to the list, but instead it wants just the object as a reference, we dereference a pointer to make it the object. So instead of being pointer list char, it'll just be list char. And then this reference here just means we're able to change it. I'm not sure why we should be able to change it, because like the search function does not assume it is not supposed to change anything. It's just supposed to search for the last occurrence. So it's okay with that, and then we're probably just going to print the result. So cout last occurrence. And then if you want to put speech marks into this, you need to escape character it. Put an escape character in. D is build errors. That's nice. Alright, I'm using the pointer operator, even though lst is not a pointer, it's just an object. So for just objects, use the dot. And then what's here? It's literally the same error. So A, B, C, D. I'm going to put a few more D's in, just to make sure the position we find is like the very last one, so E. So what we want to get returned is 0, 1, 2, 3 is the first occurrence, 4, 5 is the last occurrence of D, and 6, so 5 should be the answer, which it is. So this works, and I think that's the whole thing. It did take me a while, and I'm also still to fix this weird thing of the destructor, but like it is manageable. You just kind of have to know how a list works and just be familiar with, like, just look over this header, see what methods are in here and how can you use them, like this thing here. So if you get a similar list class, you just know like this function does this. I don't even need the comments to know that. Pretty much like if the function is well named, you should be able to see it from like the just function name. Yeah, those two. Where does he say that? Could be a hint, but maybe he just means like any files you get given, you just download. For some files we're given, we're actually asked to add like a method in, so. He means it for practical 5 for lists. Yeah. Okay. So literally, if I just go fix this last thing I had an error with, that'd be the practical done. But I didn't want to keep you guys in here. Like I've got no clue what's happening, so I might like spend an hour doing this even. So literally, I would like, if I don't have time to submit it, I would literally submit it with this error. So no. Not telling you. Okay guys, I'm gonna stop the recording.